Let's know about common roof. Number 1. Species introduction. Common roof or Eurasian roof is a species of fish from the family of perch, a typical species of the genus Ruffe. This freshwater fish, inhabiting the waters of Europe and northern Asia, near the bottom in lakes, dams, near the banks of rivers, prefers a sandy bottom or gravel. The roof can reach up to 25 centimeters, 9.8 inches, length but is usually around half its size. It is a very aggressive fish for its size. The species occurs in the basins of the Caspian, Black, Aral, Baltic and North Sea, and is also found in Great Britain, parts of Scandinavia and some regions of the Arctic Ocean basin eastward to the drainage of the Kolyma. It feeds mainly by bottom invertebrates, sometimes by small fish and some plants. The roof, in turn, is hunted by larger fishes. Suitable baits for fishing: leech, worm, caviar. Number 2. Appearance. The ruffe's colors and markings are similar to those of the walleye, an olive brown to golden brown color on its back, paler on the sides with yellowish-white undersides. The roof also has a large, spiny dorsal fin which is likely distasteful to its predators. It also has two fins on top. The front fin has hard and sharp spines, the back fin has soft spines called rays. Number 3. Reproduction. It has been introduced into the Great Lakes of North America, reportedly with unfortunate results, as it is invasion and is reproducing faster than other species. The roof has the capacity to reproduce at an extremely high rate. A roof usually matures in 2 to 3 years, but a roof that lives in warmer waters has the ability to reproduce in the first year of life. A single female has the potential to lay from 130,000 to 200,000 eggs annually. Roof will leave the deep dark water where they prefer and journey to warmer shallow water for spawning. The primary spawning season for the roof occurs from the middle of April through approximately June. The most obvious features to recognize a roof are the ruffe's large, continuous dorsal fin and its slightly downturned mouth. Number 4. Life cycle. Life for the Eurasian roof starts as an egg, like other fish. Egg sizes typically range from 0.34 mm to 1.3 mm in diameter, depending on the size of the female. If the same female has a second batch in the same season, the eggs will be smaller than the first batch. The size of the second batch of eggs are about 0.36 mm to 0.47 mm, while the first batch of eggs goes from 0.90 mm to 1.21 mm in size. If the female lays twice in one season, there is usually one in late winter, early spring and one in late summer. Hatching occurs in 5 to 12 days in temperatures of 10 degrees Celsius 15 degrees Celsius. The next stage in life is the embryonic, juvenile stage. Embryos that are freshly hatched are between 3.5 mm and 4.4 mm in size. These embryos are sedentary for 3 to 7 days, and in that time grow to about 4.5 mm to 5 mm in length. 1 week after the hatching, the young roofs start to swim and feed actively, but they do not form schools at this age. From here, the roof gradually mature until they are 2 to 3 years old, when they reach full maturity. At full length the adult roof is usually around 20 centimeters, but at a maximum of 29 centimeters. Growth is usually occurs more when the roof is in clear, blackish waters. Generally, female and male roof do not live longer than 7 to 11 years. Number 5. Ecological effects for the Great Lakes area. The introduction of the roof seems to be causing much damage to Lake Superior. This fish's invasion of the lake has not only caused problems with space, but competing with other fish for food supply. The roof has similar eating habits, but an accelerated reproduction rate compared to other similar fish. Therefore, having more roof in the water leads to less food for other fish. This fish is unique in its ability to adapt in many habitats and temperatures, resulting in success despite such factors as climate change or other biological changes. The roof also has an exceptional ability to detect water vibrations through organs called neuromasts. This trait both aids the roof in finding food and gives the roof an edge in avoiding predators. These develop into more advanced and sensitive organs as the fish matures. Of note, the perch's neuromasts weaken as it matures. The roof has the potential to overtake many other fish species, and consequently damage the Great Lakes ecosystem. Without concerted intervention, the roof have the potential to ruin Lake Superior. The roof is the first invasive species to have been classified as a nuisance by the Non-Indigenous Aquatic Nuisance Prevention and Control Program. Along with it being the most populous fish in the St. Louis River basins, it has disrupted ecosystems all across the Great Lakes. The roof and perch are competing in numbers and are also competing for food. This is a match that the rufous are winning. Number 6. Controlling methods. Ever since the roof was introduced into the Great Lakes system, scientists and fishery managers have been searching for the right way to get rid of them. In the beginning, the main method of control was to increase the walleye and northern pike populations, because they are natural predators of the roof. Other methods that have been considered are poison and chemical control. If a large school of roof is found, they can be poisoned. If some survive, however, they will rapidly reproduce. Chemicals can be targeted to act on specific species of fish. The chemical lampricide TFM kills roof, but leaves other fish unharmed. As long as a couple of the fish survive, they can move and repopulate. The problem will increase if the roof invades southern river systems. The use of pheromones is being investigated as a control. After extensive studies, scientists discovered that the roof can be repelled by their own alarm pheromone. When injured, a roof will release this pheromone into the water to warn other roof to stay away. Scientists have concluded 3 things. The pheromone repels the roof. It was unclear if it would in the beginning. The pheromone is species specific, so it would only repel the roof, none of the other fish. The pheromone is resilient to freezing, so could be used even during Minnesota's long winter season. The roof could still be controlled. By using this method, scientists could block roof from natural mating spots and produce a population decline. Their goal is to kill the species in the Great Lakes. Next video we review about common bleak.